What is 0 to the power of 0? Is it 1? Is it 0? Is it infinity? Well, usually when we have anything to the power of 0, we get 1. But if we have 0 to the power of anything, then usually we get 0. So we've got this conflict going on. What is 0 to the power of 0? Is it 1 or is it 0? Now, there's different answers to this question, but one answer is that 0 to the power of 0 is known as indeterminate. Now, there's 7 different indeterminate forms, basically where the value is ambiguous. For example, if we had 0 times infinity, well, usually 0 times anything is 0, but anything times infinity is usually infinity. So what, therefore, is 0 times infinity? And these indeterminate forms are really important when evaluating something called limits. And limits come into things like calculus, like differentiation and integration. But let's go one step further. Suppose we were to do a small number to the power of itself, like 0.1 to the power of 0.1, where we get 0.7943. What happens if we made the numbers smaller still? So if we had 0.01 to the power of 0.01, well, my calculator gives me 0.95499. And let's make the numbers even smaller, 0.001 to the power of 0.001. My calculator gives me 0.99311. So therefore, if we make that number smaller and smaller and smaller, we might think that as we do 0 to the power of 0, we get 1, because you can see that these numbers here are gradually approaching 1. And the way we could write that is that if we're trying to find x to the power of x, where we want x to be as small as possible, so we want the limit as x tends towards 0, then we can see that that value is tending towards 1. Now, does that mean that 0 to the power of 0 is 1? Well, there's a slight flaw here, and that flaw is that we're assuming that this small number here, the base, and this small number here, the exponent, the index, are the same value. But we can't necessarily assume that they're the same. For example, we could have 0.1 to the power of 0.0000001. Now, how can we prove that x to the x approaches 1 as x becomes small? Well, since you asked, we can rewrite the x to the power of x as e to the power of ln of x to the x. And this is the same because e to the power of ln of something, the e and the ln just cancel each other out, so we just get the x to the x. But what we can now do is use laws of logs to move this power of x here to the front. So we could write it as e to the power of x ln x like that. Now, if we were to substitute x as 0 into this expression here, the problem is that we end up with 0 multiplied by ln of 0. Now, ln of 0 is negative infinity. So we end up with 0 times infinity, which was one of those indeterminate forms that we saw earlier. So the fix is to rewrite this as e to the power of ln x over 1 over x. That's still the same thing. And now if we substitute in 0, we get ln of 0, which is negative infinity, and 1 over 0 is plus or minus infinity. So we have infinity over infinity, which again is one of these indeterminate forms. Now, if you have infinity over infinity, or 0 over 0 in a limit, then we can use something called L'Hopital's rule. And what that is to differentiate the numerator and the denominator. So ln x differentiates to 1 over x, and 1 over x differentiates to minus 1 over x squared. So we then simplify that, we just get e to the power of minus x. But if we substitute in x as 0 now into this, we end up with e to the power of 0, but e to the power of 0 is 1. So therefore, the final result is 1.